If you were stranded on a desert island on an exoplanet hundreds of years away from Earth, how many people would you need with you to survive? Hey everyone, Emily here for D News. Elon Musk, founder of SpaceX, recently stated that he wants to put 1 million people on Mars within a century. He'd bring everyone there with about 1,000 spaceships, each making multiple trips between Earth and Mars. If anything bad happened to threaten the existence of this colony, we could quickly replenish the population with a new batch of humans sent from Earth. This strategy works because it only takes a few months to reach Mars. But what if we wanted to colonize a world beyond our solar system, hundreds of years away? How big of a spaceship would we need? And how many humans would we need to start with to make colonization possible? Take Proxima b as an example. It's the closest planet we know about outside of our solar system. It's rocky and similar in size to the Earth and has the potential to support liquid water on its surface. The problem is we can't just hop over there. It's 4 light years away. With current technology, it would take us more than 20,000 years to get there. That's about 800 generations of humans, making this type of journey fairly impossible. Luckily, there are programs like the 100-year Starship project and Stephen Hawking's Project Starshot that are working to develop new propulsion technologies that could get us there much sooner, possibly within a few hundred years. Assuming they're successful, how many people would we need to start a colony? A study in Acta Astronautica suggests that you would need a starship filled with at least 14,000 carefully screened people to end up with a stable population after a multi-century interstellar journey. Even more people, up to 44,000, would be ideal. You'd have to account for potential catastrophes like plague, asteroid strikes, or even war. A few hundred years is a long time to be in one place. A lot of things can happen. In the study, the researchers used population genetics theory, modeling how genetics of a population changes over generations, and accounted for one catastrophe during a 5-generation voyage. Populations over 14,000 maintained good health during a trip of this length, despite relatively high inbreeding and reduced genetic diversity over time. As a colony, we'd need to do everything we could to keep genetic diversity high. It's something that plays an essential role in the adaptability and survival of a species. Think about it. Some humans would live out their entire lives on this interstellar spacecraft. As a child, you would grow up, have kids of your own with other passengers on board, and eventually grow old and die. But the only partners available to you would be the limited number of members on board that spacecraft. You'd have to be extremely careful when choosing your partner because inbreeding can lead to some serious problems. Just take a look at our early ancestors. For thousands of years, Neanderthals, our ancient cousins, lived in small, isolated populations, which led to inbreeding. By studying their fossils, researchers have discovered a range of deformities, many of which are rare in modern humans. An even larger issue with small populations may be the community's ability to formulate their own culture, acquire knowledge, and develop technology. The combination of these issues could lead to the downfall of a species altogether. We could have the same problems in a starship. Maintaining a large population with sufficient genetic diversity is key to a successful, sustainable colonization of a new world. Of course, a population of 14,000 is still a lot of people, especially when you consider the fact that the highest number of people we've ever brought into space at once is 8. In order to meet that 14,000 human minimum requirement, we're going to need a bigger ship. Or many medium-sized ships. Distributing your population across multiple ships also distributes the risk of losing that population entirely. And then maybe you'd be able to distribute the human species to another solar system. But of course, all of this assumes that humans can invent a propulsion system that's 100 to 1,000 times faster than anything we have today. So perhaps we should stick to the planet in our own backyard for now. Want to learn more about Proxima b? Check out this video here. What do you think? Would you want to be part of that 14,000? Let us know in the comments, subscribe, and come back here for more D News every day.